everyone, welcome to Maths IEC. Here's an A-level exam style question on electric fields. Please pause the video and try this. When you want to check the answers, press play. Two charges, Q and negative 2Q, are attracted by a force capital F when they are apart. The two charges were brought into contact and then placed such that they are now 2r apart. Calculate the force between them in terms of capital F. Right. Now let's see what happens when you actually bring them into contact. These two will cancel out partially. 1 minus 2, so that's negative Q. Now this is the overall charge. So what will happen now? That will be negative Q over 2. That will be negative Q over 2. So the charges are negative Q over 2 here and negative Q over 2 here. Now in this question, this is what most students struggle with. Now, let me explain this in a simpler way. Imagine this is 10, say plus 10 coulombs, the charge. This one, obviously, is twice as much, so it's negative 20. Now, when you bring them together, what will happen? 10 take away 20. So the overall charge left is negative 10 now, but that's for both of them. So this will get half of that, and this will get the other half. So we did the same thing with numbers now, so that it makes more sense. These two are both the same charge, negative. So obviously they will repel. So let's say the new repulsion force, call it F dash. Yeah, it's a mutual repulsive force, F dash. Now we are going to use Coulomb's law for this question. So the formula is F is equal to K Q1 Q2 divided by R squared. Let's apply to the first situation. F is the force, K is the constant, charges. One charge is Q, the other one is 2Q. Now we don't need to worry about the sign here because we already looked into the sign and decided on that. So Q times 2Q divided by the gap is R, so R squared. So that gives me F is equal to 2K Q squared over R squared. Let's call this equation 1. I'm going to write the same thing for the second situation. Let's do that. F dash is equal to K. The charges are Q over 2 multiplied by Q over 2 divided by 2R everything squared. So I'm just going to write it as multiplication 1 over 2R everything squared. Same as dividing by 2R squared. Simplify this a little bit. F dash is equal to K Q squared over, we have 2 here, another 2 here, 2 times 2, 4. And I have 2 squared, that's another 4. So that's 16. R squared. This is my second one. Now, how do I solve it? I need to calculate the force between them in terms of capital F. So I need to get rid of F dash, or I need to get F dash in terms of capital F. So in a situation like this, the easiest way to do is divide them by one another. There are other ways of doing it algebraically. You get exactly the same answer, but let's divide it. F dash over F. So I divided the left-hand side of second one by the first one is equal to, let's do the same thing to the right-hand side now. KQ squared over 16R squared divided by this, so multiplied by the reciprocal. So R squared goes to the top, 2K Q squared. Now you can clearly see This k here and this other k get cancelled out. Q squared and q squared, r squared and r squared. So I get f dash divided by f is equal to 1 over 32. 16 times 2 is 32. So I can get the final answer. F dash is f over 32.